Hey guys, what's up? My name is Ibad Rahman and welcome back to my channel Finico. In this video, we're going to speak about binomial distribution and what does this mean. I will also be giving you guys an example in order to understand it better. So before I can go on with the definition, what does bi mean, which I'm sure most of you are aware of? Bi means two. And binomial distribution, also known as binomial random variable, goes on to equate the number of successes in a number of tests with a given set of random variable. Now, before I can go deep into the very definition and explain you what binomial distribution is, there are some, I would say, financial jargons which you ought to know. And by the way, the binomial distribution or the binomial random variable is very much used by statisticians in quantitative methods to solve quants. So you have something known as random variable in quants. So just by the very definition of random variable, okay, that can be defined as uncertain number, okay, something which you are not aware of. That's the reason why it's a random variable. You're not aware of that number. Now, quickly looking forward, there is also known as event, okay, something known as event. An event could be regarded as the number of tests, okay? It can either be one test or two tests. If it's one test, then that is known as, if it is equals to one, that would be known as Bernoulli. I hope I'm getting the spelling right, but it's something which is Bernoulli random variable. Okay, it's Bernoulli random variable, and if it's two or more, it's known as binomial random variable or binomial distribution. You have an outcome. Outcome would be your what is the observed value of a random variable. So something which is observable. And as for binomial, we only regard as success, okay? Because binomial likes success apparently. So if you have an outcome coming from an event, which is a failure, you do not take that under consideration. You only take success under consideration. Now, you have got then mutually exclusive, okay? And what mutually exclusive basically means that no two events can be performed simultaneously, all right? So I would say no two simultaneous. And then you have got exhaustive events, which basically means there are many events can be performed together. So here you could take this as simultaneous. Okay, so again, by the very definition of binomial distribution, or also known as binomial random variable, we only take under consideration the number of successes in a test. And if there are two or more, that would be known as a binomial distribution. If it is obviously, if it's just one event or test, what we're looking for, that would be known as Bernoulli random variable, also known as Bernoulli distribution. Okay, but how do we equate that in a formula? How would you equate that into a formula? So it's basically your x factorial, okay, divided by your n minus x factorial. This is into a bracket, which would then be multiplied by x factorial. Now, what is this x and what does n stand for? X is equals to your success. Okay, as we said, that binomial distribution, binomial random variable always takes into regard of the success. And then you have got n, which would be your number of tests. Okay, and I will go on to solve an example, a question with you for better understanding. Okay, this is not the complete formula, by the way. So then this is by the Bodmas theory. This is in a bracket. This would then be multiplied by your probability, okay? And your probability is basically your probability of success, okay? Probability of success. Your probability would be to the power of x, which would be to the power of success. This would then again be multiplied by 1 minus p. Let's just say that if it would be a failure, to the power of n minus x. So this is basically your complete formula of binomial distribution. And I know this px and what does this mean. I will solve a question with you, and with that solution, hopefully you guys will be able to understand it more comprehensively. Okay? Right, guys, so I have this question right in front of you, as well as I've solved it, you know, in order to just save time, and I'll just explain you through the process. So read the question with me. It's compute the probability of drawing three black beans from a bowl of black and white beans. If the probability of selecting a black bean in any given attempt is 0.6, you will draw 5 beans from the bowl. So over here you could see that basically what it's trying to say is the number of tests, the number of events, in other words, as a synonym to test and events, is 5. Your success is 3 because you're drawing 3 black beans from one bowl, which is a mixture of white and black bean. So here you would see through this is the formula, you know, your n factorial divided by n minus x factorial into x factorial into p probability to the power of x, which is your success, into 1 minus the probability, which is your failure, to the power of n minus x. You compute all of that, you will get 5 factorial, that's your number of events, divided by your number of events minus your success rate. Oh geez, this actually needs to be 3. Yes, 5 minus 3, you would get an answer 2 factorial into 3 factorial, because that's your success, into your probability of success being 0.6 to the power of your success, which is your 3, into 1 minus your probability of success being 0.6 to the power of 5 minus 3. It's basically your number of tests minus your 3. You compute all of this in your financial calculator, okay, because you need a financial calculator in order to compute this very factorial. You will get the answer as 0.3456, also known as 34.56. So basically your binomial distribution is a success because you have computed this, okay? It's a positive figure, something which can be measurable, okay? This very random variable, something which can be measurable. It is observed. The outcome is an observed value. It's in success because it's a positive value. It's more than 2. So that is your binomial distribution. However, I've not really come to an end. I would also like to take you to the binomial tree, okay? And what does the 2-tier binomial tree means? There's also known as a 3-tier binomial tree, but would not like to get into the 3 because that would just be more complex. This is a video that what I'm trying to make is for your understanding. So I will also go on to tell you what a binomial tree is with a diagram. Right, guys, so I've gone on to draw a binomial tree right over here, and I know it probably looks a bit of probably the word complex is the right word, but at the same time it's quite interesting as well. So this is your binomial tree, and this is, you know, basically the problem and the solution towards it. But I will, you know, take you step by step. So binomial tree could again, this is a 2-tier binomial tree, but it can be 3-tier, it can be 4-tier, and the example what I've put forward to you, and before I can go on to, you know, tell you about the illustration of these figures. This is, let's just say your S is your stock price, because I took the example of stock price because it's more easy to understand how the stock price goes up, how the stock price goes down, the fluctuation of it. So let's just say that if the stock price goes up, the formula would be your S, whatever the stock price is. In this regards, we have taken stock price, which is 50. If it goes up, you take that as 1.1, all right? If the stock price goes down, you take 1 divided by 1.1, which is D. You also have to take into account of the probability. As we said, the probability of success. Your probability of success is 70%, it would go up. Okay, so it's a good buy, you know, because you have the probability that 70% of the stock which actually would go up. But at the same time, you also have the probability that 30%, because 1 minus 0.7 would give you 0.3, 0.3 into 100, if you factor that into a percent, will give you 30%, that it would actually go down. Now, if the stock price for 2 straight days, if it goes up and up, the formula basically is your 50 into 1.1 into 1.1, and or you could say 1.1 square to the power of 1.1 to the power of 2, and probability could also be said as the same thing, 0.7 square, 0.7 to the power of 2. The same concept applied over here. 50 into 1 divided by 1.1 square, your probability would be 1 minus your probability of success. Basically, it's your 0.3 square, also known as 30% square. And the most fun, which is like sort of, I also took time to understand this, what happens if stock price also goes down, but at the same time it goes up? So here, because I have the lack of space, it's basically SDU square. Okay, so there's SUD and there's SDU. So basically, if you square it, it means more or less the same thing. That, and your probability would be your 2 into your probability, which is your 0.7, 70%, into 1 minus P, which is your 7, is basically it's 1 minus 30%. And here I have gone on to counter the formula. Okay, so this is, I mean, again, you would get different. So basically, you're supposed to get in the end, in the end of the day, you're supposed to get 60.50, 49%, 50, 42%, 41.32, and 9%. And you certainly need a financial calculator in order to compute these sums. It cannot be done mentally. So again, I just hope, again, I'll explain it to you. It's 50 into 1.1. 50, why? Because you know, S is your stock price, which is 50 over here, into 1.1, because it has gone 1 time up, so it's into 1.1 is equals to 55. Your probability is, because it has gone up, your probability is 0.7, so it's 70%. Okay, now when it goes down, it's 50 into 1 divided by 1.1, because it has gone down, so that would be your 45.45. The probability would be 1 minus 0.7, 0.7 is equals to 0.3, which would give you a 30%, 0.3 into 100 would give you 30%. Okay, if that very stock price goes up twice, so it's 50 into 1.1 squared, which will give you a figure of 60.50. Okay, and then if your probability of that stock price going up also multiplies twice, so it's 0.7 square, which will give you a figure of 49%. Okay, now if your stock price goes down twice, so it's basically 50 into 1 divided by 1.1, all right, because it's going down, which is square, will give you a figure of 41.32, and your probability is basically 1 minus 0.7, which is your 0.3 square, which will give you 9%. Okay, and if the stock price goes down, from up to down and from down to up, it's 50. Basically, this is like UD. Okay, this is UD. So you just have to compute the formula. It's like simple. So 50 into 1.1 into 1 divided by 1.1 will give you a figure of 50. Your probability, because it has gone up and it has gone down, there are 2 integers over here, 2 probabilities over here. So 2 into 70% into 30% is your 42%. So this is binomial distribution. I hope that you guys were able to digest it. I hope you guys were able to understand it. I will once again come with a new video, probably about finance or economics. And if there's any questions whatsoever, if you want to ask or something you can't understand, feel free to comment. At the same time, it would mean a lot if you can like and subscribe as well. I will see you next time. Thank you so much. Cheers.